Okay, Assalamualaikum warahmatullahi wabarakatuh. Good day, everyone. Today, I would like to do paper review in regards to all pass filter and its usage. By the way, my name is Maulana. Here we go. Okay, so about the main paper. The title is Group Delay Based All Pass Filter for Abstract Sound Synthesis and Audio Effect Processing. This one is published in the 21st International Conference on Digital Audio Effects from the year 2018. So let's talk about the discrete all-pass filter presented in this paper. All-pass filter controls group delay trajectories, allowing fine-tuning each frequency of the input signal. And the output gain is unity, meaning there are no amplitude change on the signal from input to the output. The transfer function of this filter is this, and the phase response is this. The definition of group delay itself is the first derivative of phase in respect to frequency, with omega here denotes the normalized frequency. The group delay of first order all pass filter is this, and since the group delay is the first derivative of phase in respect to frequency, the phase response is the integration of group delay in respect to frequency, like the mathematical expression right here. Okay, next, there are many type of group delay presented in the paper, but I only take one example from each type. The group delay trajectory can be viewed as a function that maps the frequency axis to set of time delays. And we have three types here. The first one is the stair-stepped group delay trajectories. The next one is the modulated type, and the third one is the probabilistic. Here I also include the mathematical expression for each of these of this type, except for this one, the probabilistic, since there are no mathematical expression included presented in the paper. Okay, next. Equalization. All pass filter theoretically has unity gain as all across the frequency, but since the slope of the group delay determines the amounts of frequency spreading, the more spread frequency, the lower the instantaneous amplitude is. And by instantaneous means at this frequency, at the specific frequency. Hence, we need equalization filter to circumvent this, and fortunately, the mathematical expression for the equalization filter is also presented in the paper, and this is the yeah. Okay, next. Summary. All pass filter has unity gain. Phase of each sinusoidal signal is shifted by the group delay trajectory, and equalization filter is required to ensure that there are no amplitude shift in the harmonies of the signal. Okay, next we talk about the secondary paper. The title is Signal Decorrelation Using Perceptually Informed All-Pass Filter. This one is published in the 19th International Conference on Digital Audio Effects from the year 2016. Okay, first let's talk about decorrelation. Decorrelation is stereo shaping, the process of creating and manipulating phantom source from a stereo or more complex audio system. And the phantom source is basically like this. When you hear audio or music from headphones or from a radio, which has stereo speakers, you could hear that the sound is not coming from both of the speakers, but it is more like coming from the between those two speakers for mono signal. Or when you hear headphones, music from headphones, the sound is like formed in the middle of the headphone, middle of your head when you use it like this, and that is the phantom source. Usually, decorrelation is used for upmixing from 2.0 system to higher system, with 0.0 like right here denotes the number of subwoofer used. Like for a surround system like 5.1 and 7.1 means there are 5 or 7 speakers with one subwoofer, and etc. Okay, the all-pass filter used for the decorrelation in this paper is the Piquat all-pass filter, and this is the transfer function of that, with rho is defined as this. Pole zero angle controls the frequency at which the slope of the phase response change fastest, and the radii controls the amount of phase change. The result is the correlated signal using all-pass filter approach is less colored than other approach. Well, there are other approach presented in this paper, like the noise approach and the candle approach, etc. But since I don't have many slides to spare, I'm sorry, I can include that in this presentation. This happens because its frequency doesn't undergo amplitude change. Yeah, this is pretty self-explanatory. Okay, summary. The correlation is used to process mono audio signal into stereo or to upmix a stereo signal into more audio channel systems such as 5.1 or 7.1, and the amount of phase change and the phase shifted frequency depends on the pole zero angle and radii. Okay, that's all. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.